Welcome to our competency-based question series, designed chapter-wise to enhance your conceptual learning and five. The figure below represents the setup of Millikan's oil drop experiment, which was used by Millikan to determine the charge on an electron. So this is an experimental setup that is given to us. And in this, tiny droplets of oil in the form of mist are sprayed into chamber P. So here we are having some tiny droplets in the form of mist. And these droplets, they move downwards. And when they move downwards, they pass through the small hole in the metal plate. So it is given that some of these droplets pass through the small hole in the metal plate 1 and are ionized by the X-rays in chamber Q. So this is chamber P, and this one between the plates, it is chamber Q. And in between the plates, it is observed that the droplet which is having mass 3.2 multiplied by 10 to the power minus 14 kg and carrying a current of minus 6.4 multiplied by 10 to the power minus 19 coulomb, it remains stationary between these two plates when a potential difference V is applied. Now, based on this fact, we need to answer these two parts. Let's take part 1. What is the direction of applied electric field in chamber Q? So in chamber Q, we need to find the direction of electric field. See, this oil drop that has reached chamber Q, it is negatively charged. In order to be made this negatively charged particle stationary, it should experience a force in such a way that it should move in the upward direction. So this is possible only when metal plate 1 is positively charged and metal plate 2 is negatively charged. Then only this charge particle will be moved towards the upward direction because the force due to gravity is acting in the downward direction. So the direction of electric field inside chamber Q, it is from positive to negative because electric field always moves from positive to negative. So for part A, we need to write the direction of electric field in chamber Q is in downward direction. And this is possible when plate first is positively charged and plate second is negatively charged. Also, we know this thing that a charged particle, if it is positively charged, it moves in the direction of the electric field. But if it is negatively charged, then it will move in a direction opposite to that of the direction of electric field. So the force on this charged particle will be in the upward direction due to electric field. So that's answer for part A. Let's take part B as well. What is the potential difference V applied between the metal plates if the plates are separated by a distance of 1 centimeter? So at this point, when the charged particle is stationary, it is experiencing two forces. One is the force due to gravity in the downward direction because of the weight of the charged particle. And second is the force due to the electric field that is present in chamber Q. The direction of that field we have obtained in part A, that is in the downward direction. And the force on the charged particle due to this field will be in the upward direction. Now, when the particle is stationary, in this situation, the force due to gravity, it is equal to the force on the charged particle due to the electric field applied in the chamber Q. We know that the gravitational force is mass multiplied by acceleration, and here the acceleration is acceleration due to gravity. So I can write mg, that is equal to the charge Q on the charged particle multiplied by E, that is the magnitude of electric field. And we know this thing that magnitude of electric field, it can be obtained as V by T, where V is the potential difference and D is the distance between the plates. So I can replace this E with V by T. mg, it is equal to Q V divided by D. And we need to obtain the potential difference V. So I can take V on one side and take all other quantities to the other side. So this implies that capital V, it is equal to mgd divided by Q. So I can put the values. The mass, it is given to us. The mass is 3.2 multiplied by 10 to the power minus 14 kg. So I can write 3.2 multiplied by 10 to the power minus 14. And G, it says that we need to take it as 10 meter per second square. The distance between the plates is 1 centimeter. That is 1 multiplied by 10 to the power minus 2 meters divided by Q. And Q, it was given to us as minus 6.4 multiplied by 10 to the power minus 19. So we just need to take the magnitude because minus sign tells us what is the direction of force on the charged particle. So it will be 6.4 multiplied by 10 to the power minus 19. So this gets cancelled out with this. We are left with 2. And this, after solving it out, it becomes 5 multiplied by 10 to the power 3. So V is equal to 5 into 10 to the power 3 volt, or I can write it as 5000 volts. So this is the potential difference between the plates that needed to be applied so that the charged particle remains stationary when it moves in between the plates. And in that case, the force due to the electrostatic field will become equal to the force due to gravity. So this is the answer for part B. Keep learning, keep practicing, keep excelling.